this video on simplifying radicals. By the end of this video, you should be able to rewrite a radical in simplest radical form and differentiate between a rational number or an irrational number. Alright, so previously we discussed rational and irrational numbers and what they look like. Now we're going to actually look at our radicals numbers, and we're going to learn how to simplify them to where nothing else can be done to them. But before we start, there's a few things we want to remind ourselves of. If we have this symbol right here, this big like check mark, that is called a radical. That's what the symbol is called. Okay, the number underneath the radical is called the radicand. And then there's this number that can sit on the check part here, and that is called the index. If there is no index written there, you assume the number to be 2. And we're going to limit ourselves to the 2, which is a square root in Algebra 1. Alright, so take a second and see what you can remember without a calculator of the perfect squares. So what I mean is, what is 1 squared? What is 2 squared? What is 3 squared? And then come back once you've done that. So here are the perfect squares up through 15 squared. The reason I'm having you do this is it's a good idea to recognize a perfect square when you're simplifying radicals, because it's going to make your life a little bit easier. So I'm going to try some just perfect square examples to let you understand. So if I were just to ask you, what is the square root of 81? Most of you could tell me that the square root of 81 equals 9, because this is 9 times 9. Here's why this works. 9 times 9. So remember, there's no number on our index here because it's 2. What that means is you're looking for 2 of the same numbers for one of them to come out from underneath the radical. Okay, let's try that again. Notice there's no number on the index, which means 2. Well, 144, we recognize that 144 is 12 times 12. So this is really 12 times 12. So because there's 2 12s, that means one of them is going to come out from under the radical. But there's a number in front. This says 3 times whatever the square root is. Well, the square root is 12. So we need to say 3 times 12, which is 36. Okay, so before we go any further, let's take a look. 36, this is a whole number. It's an integer. That makes it rational. 9 is a whole number, natural number. It's an integer. That makes it rational. Okay, when there's no radical left in your answer, because we were able to simplify this down, it's called a rational number. So 225 right here, that means that's 15 squared. So this is really saying 15 times 15. Because our index is 2, you need 2 of the same numbers to take one of them out. So you'll have a 15, and there is already a 4 on the outside. And 15 times 4 is 60. That's a pretty normal looking number. That makes it rational. All right, one last one. 196, that is 14 squared. Remember, you need 2 of the same for one of them to come out, so this is really saying 14 times 5, which is 70, which makes that a rational number. All right, let's flip this over to the back of those notes to number 5, and let's look what happens if the number under the radical is not a perfect square. Okay, so 32, not a perfect square. What you want to do is you want to start breaking it down into multiples. What factors multiply together to get me to 32, and start looking for pairs of numbers to pull out from underneath the radical. So let's take a look at what I mean. So 32, there's several ways we could make 32, but the one I thought of off the top of my head was 2 times 16. So we want to break down these numbers to either pairs or prime numbers, and a prime number that the only way to make it is to multiply itself times 1, meaning there's no other factors to make it. So the only way to get 2 is 2 times 1, so we cannot break 2 down any further, but 16 can break down. There's a couple ways we can break it down. I'm going to show you one way. And one way is 4 times 4. Okay, once you have two of the same number, we're going to stop here. Okay, I have two of the same number. That means one of them can come to the outside, out from underneath the radical. So I'm going to bring a 4 out. Okay, we've rewritten the 16. So what I want you to do is I want you to cross off the 16 so you're not looking at it. Okay, we rewrote 16 as 4 times 4, so we've already dealt with that. We had a pair, because remember, if you're taking a square root, you need two of the same to bring one out. Now, I have this 2. He has no partner. There is nobody else that matches with 2. What happens if there's not 2, it has to go back under the radical. So it's a 2, so I'm going to write the 2, but it has to be under the radical. So the square root of 32 is 4 square root 2. And that is a number, it still has a radical in it, and I can't simplify it any further. That's going to make it an irrational number. Okay, let's try this again. This takes a little bit of practice. So 180, you're looking for two numbers that multiply together to get us to 180. I noticed, like off thinking about it, this ends in a 0, which means it can be multiplied by a 10. So we could do 18 and 10, but this can be done multiple ways and get the exact same answers. These are not prime numbers. I can break these down. I can break 10 down to 2 times 5. Now 5 times 1 is prime. This won't break down, neither will the 2. So I can't take these down any further. I'm going to cross off the 10 because I rewrote it as 2 times 5. Now 18, I can write a couple different ways. I could say 3 times 6 is 18. I rewrote 18, so I'm going to cross it off. 3 will not break down again, but 6 can, to 2 times 3. So I'm going to cross out the 6 because I rewrote it as 2 times 3. Now we got a whole lot of stuff going on here. Let's look for pairs that we could take one of them out. I have a pair of 3s. You see that? There's 2 3s, so I'm going to bring a 3 out from underneath the radical. So we know we are going to have numbers that go back under the radical. So I'll put that there. I have a pair of 2s right here. So a 2 is going to come out. So what's going to happen is you're going to multiply these together. Okay. Then I have this 5 sitting here. This 5 has no partner. That means he needs to go underneath the radicand. So to finish this off, we have to multiply the 3 times the 2 to get 6, and then we'll have the square root of 5. So 6 square root 5 is the square root of 180. This number, because there's still a radical in it of a non-perfect square, that makes it irrational. All right, hopefully we're starting to pick this up. Let's try this again. So the square root of 147. So I need to find two numbers that multiply to 147. I did this ahead of time to kind of help us out here. I got 3 times 49 is 147. 3 is prime and cannot break down any further. So we got to look at 49. And what I know about 49 is it is 7 times 7. Okay, I've rewritten 49 as 7 times 7, so I don't want to look at the 49 anymore. Now I'm seeing a pair of numbers. I'm seeing 2 7s. You see right here? That means a 7 is going to come to the outside of the radical. So I'm going to write my radical in here. So when you have a pair, that means 1 comes out. And I have this 3. He's got nobody to pair with. If he has no partner, it's got to go back underneath the radical like that. So that since I was only able to take out one number to the front, it's just going to stay 7 and then square root 3. So we have a number that's being multiplied to the square root of a non-perfect square that makes this irrational. Okay, let's keep trying. Practice makes perfect. So the square root of 175, I found a pair for us that can work to break us down. A factor pair, we have 5 times 35. I picked 5 because I noticed it ended in a 5, so I figured that would work. 5 is prime and will not break down again, but 35 can be rewritten as 5 times 7. So I'm going to cross off the 35 because I rewrote it. Now 5 is prime and so is 7. So I can't break it down any further. So what I want to do here is I want to look for some pairs. I have a pair of 5s, meaning there's 2 of them. One can come out. I'm looking for other pairs. I'm going to put my radical here, so if I need to put something back underneath it, I have a place to put it. There's no other pairs, but I do have a single 7. That means the single 7's got to go back underneath the radical. And then I'm just going to write them together. It's the 5 times the square root of 7. It's 5 times a non-perfect square, which makes it irrational. All right, hopefully we're starting to see some patterns here. Let's try it again. Okay, 48. 6 times 8 is one that works really well. 6 times 8. 6 can break down to 2 times 3. I rewrote the 6, so I'm going to cross it off. 8 can break down to 2 times 4, so I'm going to cross off the 8 because I rewrote it. We don't want to count it more than it is. So this 2 is prime, 3 is prime, 2 is prime, 4 can break down again. 4 is actually 2 times 2. So I can cross off the 4. Now I got a whole bunch of stuff going on here. Let's see what I've got. So I'm going to put my radical so I have places to put things. I have a pair of 2's, which means a 2 is going to come out in front of the radical. Look though, I have another pair of 2's right here. So I bring another 2 out. It's got to multiply to whatever's in front. Okay. Then I have this 3 that's alone. If you have a number with no partner, that number goes back underneath the radical. So my final answer for the square root of 48 will be 2 times 2, which is 4. And then I have the square root of 3. That's a rational number times an irrational number is going to give me an irrational number. All right, one last one and let's see what happens. So 54, there's a couple ways we can make it with factor pairs. I'm going to just write 2 times 27 because it doesn't matter which factor pair we use as long as they actually multiply to 54. You'll get the same answer. 2 is prime, but 27 can break down. I'm going to say it's 3 times 9. So I rewrote the 27, so I don't want to leave the 27 there. 3 is prime. It will not break down again, but 9 can be rewritten as 3 times 3. So I'm going to cross off the 9 because I've got it rewritten as 3 times 3. So I'm going to put my radical down here so I have places to put things, and I'm going to look for pairs. I have a pair of 3's, which it will come means a 3 will come to the outside. Okay, I don't see other pairs, but what I do see is I have a single 3 and a single 2. Just like before, even though there's 2 of them, there's a 3 he has to go back in, but the 2 also has to go in. And so just like in the outside, if you're putting them back in, you're going to multiply them together. Okay, so our final answer here would be we have a 3 on the outside, and we'll have the square root, and 3 times 2 is 6. So we simplified this. It still has a radical in the answer. That makes it irrational. All right, hopefully that got you going in the right direction. Take a look at the practice assignment. Upload it to Canvas when you're done. Let me know if you have any questions, and I'll see you in class.